In this video, we've got a road sign warning of merging traffic, which consists of a circle inside an equilateral triangle. And we want to know what the radius is of that circle. Well, there are a number of different approaches to do this. One of them is going to be with using trigonometry, and there's another one without using trigonometry. In this video, I'm going to use the approach using trigonometry, and in the next video I'll try to do one without trigonometry. So firstly, I'll represent this triangle here again, but on a larger scale, just so that we can see it more clearly. Now I'll insert the circle, and also I'll name the vertices. The vertices will be A, B and C. Now we need to find the centroid of a triangle. That means the center of this equilateral triangle. And this is a point of intersection of all three medians of a triangle. So you say, what is a median? Well, a median is defined as a line that connects the midpoint of a side and the opposite vertex of the triangle. This is a median. And because this is an equilateral triangle, the median will divide the base into two equal parts. We still don't know where the centroid is. We need to do the same thing with the other sides. And this point of intersection at this moment will give us the centroid here. Now it is worth knowing that the median is divided in the ratio of 2:1 by the centroid of the triangle. So this might be 2:1. And so by knowing the length of this median, we should be able to find out what the radius is. It should be obvious now that what we're interested in is finding the length of that median. So let's look at that triangle. So since each side of our triangle is 30 centimeters, then this side will be 30 centimeters, and the bottom side of the yellow triangle will be half of that, which will be 15 centimeters. And we do not know what the height is, so we're going to be looking at the height. But we do know a few angles. Since this is an equilateral triangle, we know that this is going to be an angle of 60 degrees. And we know that this is a right angle triangle. And we also know that this angle will be 30 degrees. And that allows us to use trigonometry to find the height, which we might call h. So let's bring that triangle down. And now we're able to calculate the value of h using these trigonometric ratios. Which trigonometric ratio we use depends on what values we have. We have the longest side, and the longest side will be called the hypotenuse. The other sides will be depending on which angle we're going to be using. If we use angle 60, this one, then in that case h will be our opposite side and the base will be our adjacent side. So we are able to use the ratio sine theta is opposite over hypotenuse, which is sine 60 is equal to h over 30. So that h now will become 30 times sine 60. Using the calculator, make sure you've got it in degrees, not radians. This will equal to 15√3. This is the exact value. Now we could also use the ratio opposite over the adjacent. In that case, we would be using tan theta. That's still 60 degrees. This will be tan 60, which is h over 15. So we can find out what h is. And h will be 15 times tan 60. Again, try the calculator in degrees. which you find is also equal to 15 root 3, exact. And as I said before, the median is divided in the ratio of 2:1 by the centroid. So if we divide this by 3, we will find out what the radius is. And so the radius, if we reduce this down, will be 5 root 3, exact. But we can find out what it approximately is, and it is 8.66 centimeters. Now I must point out here at this point that I used the fact that the median is divided into 2:1, where the one part of it is radius. But in those cases, you are not to know this, and you will need to calculate the radius now. So how will you calculate the radius, not knowing that the radius is a third of the height? Now I want to show you that we could have used trigonometry without needing to find out the length of the median. All we needed to do was to use another triangle, the smaller one, where it's got only the radius. Any of the small triangles could have been used, and there are 6 of them. Each one of those has the radius. And remember that half of the base was 15 centimeters, so we do have 15 centimeters. And we know that this is going to be a right-angled triangle. So being an equilateral triangle, since each angle in the equilateral triangle is 60 degrees, then we know that the green triangle will have an angle of 30 degrees. And the last angle will therefore be 60 degrees. So once again, we can use the trigonometric ratios to find the value of r. And using the angle being 30, we will use the opposite over adjacent, which is going to be a tan. So tan 30 will give us the radius over the adjacent 15 centimeters. That means that our radius is equal to 15 times tan 30. Once again, we do this on the calculator, and our answer will be 5 root 3, just like before, which turns out to be 8.66 centimeters. So as long as you've got right-angled triangles and you can identify their sides and the angles, you can use the trigonometric ratios to work out most problems. This example was made simple because we had an equilateral triangle. Please let me know if you would like me to do a circle in a right-angled triangle or a circle in a scaling triangle. And remember that by pressing a subscribe button and by pressing on the like button, you will be helping me a lot.